So that's how you get the amplitude, right? So you can basically, just looking at this particular equation, you can just separate your amplitude and your phase components, okay? When you are doing your Fourier expansion involves the phase and the amplitude, okay? Phase or magnitude. So just observing this equation, you can see that this is my amplitude part, and this particular part over here, this particular part indicates my phase component, okay? So that's why, since we needed to find the amplitude of the first and the third harmonic, we just use the amplitude component of this equation. Oh, okay. And since it says n starts with 1 and all odd values, so that's why we we just create a short table and write the definition of all n values, okay? So just looking at the phase values, you can see that when n is equal to 1, you get the, when n is equal to 1, you get the fundamental frequency, okay? Just observing this particular part over here. So 1 is equal to fundamental frequency, right? When n is equal to 1, you get the fundamental frequency. When the second value of n, since it clearly states that n is of 1 and all odd values, okay? So second value of n is 3. So when n is equal to 3, that is when my first harmonic will occur. When n is equal to 5, my second harmonic will occur. 7, n is equal to 7, my third harmonic, and so forth, right? So we needed to calculate the first and the third harmonic. So just observing from the table, the first harmonic will occur when n is equal to 3, and the third harmonic will occur when n is equal to 7. So now just taking this magnitude formula, you just need to find the amplitude for the first harmonic when n is equal to 1. And when n is equal to 7, you find your third harmonic. So this is how you get your amplitude for the first harmonic. And this is how you get the amplitude of your third harmonic, right? Moving on to the second part of this question, it says the bandwidth of the system, if the following upper limit is imposed, right? The amplitude of the nth harmonic is greater than 1/16 of the amplitude of the fundamental frequency. So what this indicates, right? What will be the n value, right? Or what will the bandwidth be when the upper limit, right? Oh, it says that, sorry, the amplitude of the nth harmonic will be greater than 1/16 of the fundamental frequency, right? So it says the amplitude of the nth harmonic, right? It says we need to find the bandwidth, right? So the formula for bandwidth is basically given as n minus 1 times f naught. Okay, bandwidth is basically given by n minus 1 times f naught. So we just need to find the n value which gives us, right, which gives an amplitude greater than, right, based on this particular statement over here, right? It says the nth harmonic should be greater than 1/16 of the fundamental amplitude, isn't it? So fundamental amplitude will occur when n is equal to 1. Okay, so that is why 8 times a, right? A value is 10 from the equation, right? 8 times a, just taking this equation over here, this component, the amplitude component, 8 times a divided by n times pi whole thing squared should be greater than 1/16 of 8 times a upon the fundamental harmonic will occur at, the fundamental amplitude or the fundamental harmonic will occur at n is equal to 1, isn't it? So in place of n, you write 1, right? Or rather, if you don't write 1, you'll still get the pi value. So 8 times a divided by pi squared. Okay, so you understand how we get this particular equation? It is just from this particular statement over here. Okay, the highlighted, underlined statement over here. Is that fine? Is that fine, guys?
Yes.
Okay, so just from this particular statement over here, we can write our equation, right? So it is 8 times a upon n dot, or n times pi whole thing squared. So we need that amplitude of the nth harmonic to be greater than 1/16 of the fundamental harmonic. So 1 upon 16 dot 8 times a whole thing upon fundamental will occur at n is equal to 1. So upon 8 8 upon a 8 times a whole thing upon pi squared, right? So this is the equation we get from this particular statement over here. Now we need to find this nth harmonic, right, in order to find our bandwidth, right? So what we need to do is solve for n, right? If we solve for n, we get n is less than 4. Okay, so since n has to be less than 4, and based on the statement over here, n is all odd values, isn't it? Starts with 1 and n values are odd. So just observing this particular statement, n has to be less than 4. So the immediate n value based on this statement would be 3. So we take n is equal to 3. Okay. When you solve this particular equation, over here, we get n is equivalent to 4. Okay. So n is less than 4. And based on this statement, n is equal to 1 in all odd values. We have to consider n is equal to 3. Okay. Now we know n value that will give us, n value that is going to give a magnitude or an amplitude greater than 1 upon 16 of the fundamental amplitude. Okay. Now we need to find the bandwidth of the system if the following upper limit is imposed, right? We need to find the bandwidth. We know n value, so the bandwidth is basically given by n minus 1 times fundamental frequency, which is basically equivalent to the n value that we found, that is 3. So 3 minus 1 into f naught, which is basically equivalent to 3 minus 1 is going to give me 2. 2 times f naught, right? Which is equivalent to, you go back to this particular equation, it says the period is 20 milliseconds. So if the period is 20 milliseconds, you can find the frequency, isn't it? So frequency is basically 1 upon 20 milliseconds, which is going to give me 50 hertz. Okay, that is my fundamental frequency. So substituting the f naught in this particular part, so 2 times f naught is 50 hertz. So 2 times 50 is going to give me 100 hertz. So my bandwidth becomes 100. Okay, 100 hertz. So that's how you get the bandwidth. Now moving on to the third part of this question, the data rate of the system, right? Data rate of the system. Since we know, right, if we go back to this particular question over here, the statement says the period is 20 milliseconds. So in a period, what happens? We have a whole complete cycle. We have two sides of a particular signal, isn't it? So we have an up and down signal, right? If it's a triangle, so it will have an up component and a low component as well. If it's a sine wave, right, it will have a up and low component as well, right? If it's a square wave, we have an up and a down side as well, isn't it? So what happens in this particular case? So a period is of a one whole cycle, isn't it? And we need to know the data rate. So if we consider since whenever we are dealing with a digital data, we are basically dealing with square waves, isn't it? Whenever we are dealing with digital data, we are dealing with square waves. Agree or no? We have one value and 1 0, isn't it? Right? The upper part will represent the 1, the lower part will represent 0. So that basically in one cycle, you are transmitting 2 bits. Agree? Do you guys agree?
Yes.
Okay, right? So basically, when you're considering a square wave, basically we are basically transmitting 2 bits per second. Okay. Now, based on this, what will be the time taken for one bit to be transmitted? That would be, if 2 bits take 20 milliseconds, 1 bit will take 10 milliseconds, isn't it? So in order to find the data rate, it will be 1 divided by 10 milliseconds, isn't it? 1 bit divided by 10 milliseconds. So 1 bit divided by 1 upon 10 milliseconds is going to give me 100 bits per second. Okay, TB is 10 milliseconds. Time for 1 bit. So 1 divided by 10 milliseconds is going to give me 100 bits per second. The other way you can do is, you could have, rather than doing all this part, just know that there is two bits being transmitted in one cycle, isn't it? So you could have done 2 bits divided by total number of bits divided by total number of time taken to get our data rate. So 2 bits divided by 20 milliseconds is also going to give me 100 bits per second. Agree? So that's how you get the data rate of this particular system. Okay. Now calculate how many harmonics are needed to obtain the bandwidth of 700 hertz. So bandwidth is basically given by n minus 1 f naught, right? So we need to find the how many harmonics are needed, right? When we mean harmonics, we need the n value, right? So if we know the n value, we can use this particular table to calculate the nth harmonic, isn't it? Or name that particular harmonic. So based on that, we know our f naught is 50, right? F naught is 50. Remember, calculated our f naught over here. That is 50 hertz. We used it in this particular question over here. F naught is 50, right? F naught is 50. We need to calculate our n, and we know our bandwidth is 700. So 700 is equal to n minus 1 into 50. Solving for n is going to be equivalent to 14. Okay, n is going to be equivalent to 14. Now, n cannot be even value. Okay, n cannot be an even value. It has to be a odd number, isn't it? Based on this particular statement over here, n is equal to 1 and all odd values. So if you take a smaller value, what will happen? If you take a smaller value, the frequency, this n times f naught value will decrease, isn't it? So the bandwidth will decrease. If you pay attention to this particular question, right? If this particular statement, if n is small, the bandwidth will also decrease. If you decrease n, the bandwidth will also decrease, isn't it? But you need a bandwidth of 700 hertz. So what do you need to do? You round it up. Okay, you take a higher value in order for the bandwidth to be at least 700 hertz. So n is equal to 15, right? If n is equal to 15, if you keep on drawing this table and going up till the value of n is equal to 15, you'll come across this 7th harmonic, right? So when n is equal to 15, that will be your 7th harmonic. Okay, or you can directly start listing. Your first harmonic will start at n is equal to 3. So n is equal to 3, 3, 5, 7, 9, 11, 13, 15, and 17, and so forth. So 3 is first harmonic, second harmonic, third harmonic, fourth harmonic, fifth harmonic, sixth harmonic, seventh harmonic, right? So when n is equal to 15, you will be able to calculate how many harmonics are needed to obtain the bandwidth of 700 hertz. So you get a n value of 15 based on this particular formula. So n is equal to 15 is basically equivalent to the 7th harmonic. Okay, is that fine?
Sir,
Yes.
what happened if the n is 13?
Okay, like I said, if you go over here, if you observe this particular formula, what happens if you decrease n? What will happen to the bandwidth?
Will decrease.
It will decrease.
Yeah.
But you need a bandwidth of what? 700 hertz, isn't it? So now you get a value of 14, right? In order to get a bandwidth of 700 hertz. So if you decrease this n value, this 14, what will happen to the bandwidth? It will also decrease.
Yeah.
You'll get somewhere less than 700 hertz just from observation. But you can directly substitute. You'll get a smaller value of bandwidth, but you want at least a bandwidth of 700 hertz. When you are transmitting data in a real world scenario, if you need that much of allowance, what happens? You can't decrease the number, or you can't decrease the size, isn't it? Maybe you can increase the size and you can trim it off, isn't it? So that's why you need to increase the value, right? If you increase the value,
I get it.
yeah. So if you increase the value, the bandwidth will slightly increase, but it will remain within your requirements. Okay. So that's how you get the 7th harmonic. Now calculate the wavelength of the signal. Now calculate the wavelength of the signal. So wavelength is basically given by
lambda FC.
Yeah, lambda f is equal to c is basically equivalent to speed of light, isn't it?
Yeah.
Oh, so lambda is my wavelength, right? So lambda times f is equal to c. C is my speed of light. Frequency is what we have, that is 50 hertz, right? From the question, we just need to find our lambda. So solving for lambda, right? Lambda is basically equivalent to c divided by f. So which is basically equivalent to 3 times 10 to the power of 8. 3 times 10 to the power of 8 is speed of light, okay? Divide by 50, which is going to give me 6,000 kilometers, right? So lambda size is 6,000 kilometers. And now you wonder why C? So have you seen how when we are dealing with wireless communication, we are dealing with space, isn't it? So when we are dealing with space, right, this data is traveling at a speed of light. That is why we can't see the data, isn't it? Or it is traveling in light. Or whenever we are dealing with communication systems, we are dealing with speed of light, okay? Fiber systems are also traveling using light to travel, isn't it? The data is being traveled using light. So that is why C value is the speed of light, okay? So whenever you are dealing with this, whenever you're trying to find lambda in communication system, remember we most of the time will be using 3 times 10 to the power of 8. So that was regarding the lambda value. Next part is draw an approximate frequency diagram for the waveform using three harmonics, sorry, right? And if identify the amplitude and the frequency on the graph. Now, when we are drawing all of you have done Fourier transform, isn't it? Fourier transformation. So when you are drawing the Fourier transformation, it is always magnitude upon or magnitude against frequency. There's a magnitude plot and there is a phase plot, isn't it? So for this particular case, it just says draw a appropriate, right? Draw an appropriate frequency diagram. So most of the time when you are drawing your Fourier transform graphs, it is the magnitude plot always, most of the time, isn't it? So we can draw a magnitude against frequency plot, okay? That would be the most appropriate one. So remember, this is what we got. This is the formula for the magnitude, right? Directly from the equation. So we can take this formula, right? And identify our first harmonic, the second harmonic, and the third harmonic values, isn't it? We just need to use the 3 harmonic values. So basically we can start with n is equal to 1, n is equal to 3, 5, and 7. That is my first 3 harmonics, isn't it? So what I can do is find the amplitudes, right? If I find the amplitudes up till n is equal to 7, the first 3 harmonics, right? This is my fundamental harmonic. The second and the third harmonic values, right? If you directly punch in the values in the calculator, you should get the fundamental amplitude of 8.11. The first harmonic is given by 0.9. We calculated in the first part of this question, right? Over here, 0.9. The third harmonic is given by 0.165. Okay. The third harmonic is given by 0.165. The second harmonic value we need to calculate, which is going to be 0.324, right? So these are all when n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 1. Sorry. Yeah, when n is equal to 1, n is equal to 1, n is equal to 3, n is equal to 5, and n is equal to 7, isn't it? So the frequency values will be all multiples of n times f naught, isn't it? Here you go. Here you can see this particular part states that the frequency values will be n times f naught, isn't it? So that's how you get this particular value. You know our f naught is 50. So when the magnitude, when n is equal to 1, the magnitude is 8.11. The frequency will be n times f naught. So n value is 1. So if n value is 1, you get an amplitude of 8.11 and the frequency will be 50 hertz. When you have n is equal to 3, you get an amplitude of 0.9. Okay. The frequency will be n times f0. So n value is
3.
n value is 3. So 3 times 50 is
Yeah.
150 hertz, right? Same way, 5 and so forth. So this particular line is basically n times f0. And this particular part over here is all the amplitude formula, right? You just need to punch in the values in this particular formula for n, all n values going from 1 until 7. So keep punching in the values and finding the amplitudes. And this a value will be 10. Just vary this one value, this n value. Okay. So that's how you get this particular plot over here. Okay. So we had already calculated for this, the third harmonic and this first harmonic. We just needed to calculate for the second harmonic, which is 0.324 using this particular formula. And the frequency part could be just represented by n times f0. So is that fine? All of you understand how we get this particular plot? This is the amplitude. Okay. So with that, we conclude this week's tutorial. So does anyone have any queries? I'm really sorry at times. What happens is you can see I have already consumed 1 hour, isn't it? It was a pretty simple tutorial, but it is lengthy. You see, it's lengthy tutorial. So that is why I have to really just directly explain you guys, but I cannot go in depth of each and every calculation directly. So if you need any help regarding anything, you go over it, you try to punch in the values and see if you get the same values or not. Okay. Is that fine, guys? If you have any queries, you can ask me right now. But it's all punching in the values now, right? I have just gone over the formulas. You can substitute the values and check whether the equations, you get the correct values or not. But you should be getting the same values for all of this. Whenever there is an error in the calculation, I'll point it out, okay? So anyone has any other question? Anything regarding your lab or anything regarding your lectures that you want me to go over?
Just regarding the lab.
Yeah.
Yeah, I think I did submit earlier before you mentioned something about the conclusion and the introductory.
Okay.
For lab 2. So I was wondering if you could allow me to redo that part and then resubmit it.
Okay, no worries. You can resubmit though late. How should I grant? You can, right? Okay, if you are able to resubmit there, that's fine, right? I won't deduct mark. You can edit it and you can resubmit, okay?
Okay.
This goes out for everyone. If you need to change your conclusion, please do so. I won't deduct any marks for that, okay?
Thank you.
Okay, no worries. Anyone else has any particular query that you want me to address? If not, then we'll end this particular session right over here. Okay, no worries, right? I'm always here to help you guys. Just drop me a Viber message, right? That is the most quickest way to actually reach me. Emails are also there. Just drop me a message. With this, I'll just conclude this session and see you on Monday, right?
Yeah, thank you.
Thank you.